Intermediate algebra for statistics. Powers of polynomials. Product of binomial conjugates. Lesson objectives. Find the power of a monomial. Simplify the square of a binomial. Lesson objective. Raising a product to a power. If n is a counting number, then the quantity x times y raised to the nth power is equal to x to the nth times y to the nth. In words, to raise a product to a power, raise each factor to the power. Let's try this rule with numbers. Imagine we have the problem, the quantity 2 times 3 raised to the third power. If we were to think of 2 times 3 as the base, then we would have the base multiplied by itself 3 times. Since this is all multiplication, we could regroup and say these are a base of 2, these are the base of 3, and notice we have 3 factors of 2 and 3 factors of 3. And we had the result that the rule is telling us. If we have a monomial raised to a power, then each factor gets raised to that power. Let's use the calculator to verify our answer. If we take 2 times 3 and raise it to the third power, we get 216. But that is also equal to each factor raised to the third power, and that gives us the same answer. So this and this are equivalent. Example 1. Perform the indicated operation. Number 1, we have the quantity x times y raised to the 7th power. Number 2, we have 7x, and that quantity is being squared. And number 3, we have negative 2x raised to the 4th power. So for number 1, using our rule, each factor gets raised to a power of 7, and we are finished. Number 2, 7's a factor, it's squared, and also x is also squared. 7 times 7 is 49, so our final answer is 49x squared. Number 3, the base of negative 2 is raised to the 4th power, and x is raised to the 4th power. Negative 2 times negative 2 times negative 2 times negative 2, which is a positive 16, and then we have x to the 4th. Lesson objective. Squaring a binomial. A plus b is a binomial, 2 terms, and squaring it means it looks like this. We are raising this to the 2nd power. Now what does that really mean? That means the quantity a plus b times the quantity a plus b. If we were to FOIL this out, a times a times b times a, and b times b, so we get a squared plus ab plus b squared, combine like terms, and we see that ab plus ab is 2ab, so our final answer is a squared plus 2ab plus b squared. Now if the binomial involves subtraction, the idea is essentially the same. A minus b quantity squared is the same thing as a minus b times a minus b. Foiling it out, we get a squared minus ab plus b squared. Combine like terms, and we get a squared minus 2ab plus b squared. So this is known as the square of the sum. A plus b quantity squared is a squared plus 2ab plus b squared. A minus b quantity squared is known as the square of a difference, and that's a squared minus 2ab plus b squared. In words, the square of a binomial equals the first term squared plus, or if it's subtraction, minus twice the product of the 2 terms plus the 2nd term squared. Now the way I like to sort of think about it, I square the first, I double the product, double means multiply by 2, the product of these two, and then I square the last term. So square the first, a square, double the product, a times negative b is negative ab, double it, and then square the last term. Negative b squared is negative b times negative b, which is b squared. Square the first, double the product, square the last. Let's do some examples. Example 2. Number 1, x plus 7 quantity squared. Number 2, 5t minus 4w quantity squared. Number 3, 3r squared plus 2y squared quantity squared. Let's do the easiest one first. Number 1, x plus 7. We can think of x as a, b is 7. So a squared becomes x squared plus 2 times x and 7 plus 7 squared. This becomes x squared plus 14x plus 49. Square the first, x squared, double the product of 7 and x, so 2 times 7x is 14x, and square the last. Positive 7 squared is 49. Now, of course, if you forget the formula for squaring a binomial, you could always write it out. X plus 7 quantity squared is x plus 7 times x plus 7. Full it out, you'll get x squared plus 7x plus 7x plus 49, which simplifies to the same answer using the formula. Number 2, we can think of a as 5t minus b, which is 4w. So we take 5t, square it, minus 2 times a and b plus b squared. So we get 25t squared minus 40tw plus 16w squared. So square the first. 5t squared is 25t. Double the product. 5t times negative 4w is negative 20tw. Double it and you get negative 40tw plus the last term squared, negative 4w times negative 4w is a positive 16w squared. And again, if we were to write it out and use the full method, we would get the same answer as using the formula. Number 3, the hardest. Take the first term, square it, double the product, square the last. So in this example, we have a factor of 3 and we have a factor of r squared. Both these terms are going to be squared. So that becomes 9 r to the 4th. 2 times 3 times 2 is 12. R squared y squared. And then the last term, 2y squared squared. The 2 gets squared, you get 4. Y squared squared is y to the 4th. Here's a common mistake with squaring a binomial. It is very easy to want to just square the first term and square the last term and that's it. But this is not correct. This is a mistake. Let's look at why. Let's let a be equal to 3 and b be equal to 4. So a plus b quantity squared is equal to 3 plus 4 quantity squared. Well, 3 plus 4 are like terms. We can combine them and we get 7. Square 7, you get 7 times 7, which is 49. Now, that is not the same thing as 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. This quantity added up is 25, which is not 49. Verifying our calculator, the quantity 3 plus 4 squared is 49. So I take the first term and square it. That'd be 3 squared. Double the product, so that's 2 times 3 and 4 plus the last term squared, which would be 4 squared. That gives me 49. But if you just square the first term and the last term, you don't get 49, you get 25. So let's look at a visual of multiplying a binomial by a binomial. So here we have square a. This length is a, this length is a, so a times a is a square. This square here. If I add b to this length, we now have a plus b times a plus b, and that is equal to this square, which is equal to all of this. So this would be a squared plus an ab and an ab plus a b squared. So it is incorrect just to think that a plus b quantity squared as an a squared plus a b squared because you are missing this area here. Thanks for watching.